So to get us started today, we're going to spend a whole lesson really focusing on just recognizing a very special case of polynomial. And it's really important. We've taught this a variety of different ways in the past, but it's really important that we're able to recognize this one right off the bat and be able to tell that this is the approach we're going to take just by recognizing it. So you would know how to recognize someone, a person. You would definitely recognize maybe your best friend, or maybe it's your mom, or maybe just someone that you would recognize would beyond the shadow of a doubt. And we want to be able to get to that point here. And so there are really a couple main characteristics that we have to be able to see. So the question that I really want to ask you first is, what patterns do you see? Looking at these 6 different questions that you have on your notes, what are the patterns that we see? And then how can we use those patterns to ultimately factor these? And so we've been looking at GCF factoring, but now we're going to look at something called the difference of 2 squares. So I've already kind of given away a few hints there. So the first thing you should notice is that in every single one of these, there are 2 terms. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, right? So every single one of these has 2 terms. So that's the first thing, all right? The first thing that we have to recognize here is that if this is going to be that fancy one that we recognize, it has to have 2 terms and only 2 terms. It can't have more. It can't just be 1 and it can't be 3. It's got to have 2 and only 2. The next thing I want you to notice is the operation. Hopefully you're saying that, oh, subtraction, 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 subtraction. So subtraction has to be the operation. And if it's going to be subtraction, another word we use for that is we call it the difference. Okay, the difference. So difference means subtraction, right? And then the last observation that I'm hopeful you'll see is that this is probably the hardest one, unless you got an eye for it, is that if you look at every single one of these terms, you'll notice that they are all perfect squares. Obviously, x squared is a perfect square. 16 is a perfect square. 4 is a perfect square. 1 is a perfect square. 25, x squared and y squared are both perfect squares. 16 again, and x squared. 121 is a perfect square. 81, 4, 36, 49. All of these are perfect squares. So that's our third requirement, is that they have to be perfect squares. Perfect squares. So if you are good at recognizing those perfect squares, you're going to be in good shape. But if you don't know your perfect squares, you might want to brush up on those from middle school to make sure that we're good. So here's the key. We're about to factor each of these, but it follows the same pattern every single time. So if it meets these 3 criteria, 2 terms, subtraction, and a perfect square, both perfect squares, then we can do the following, okay? So here we go. Let's make sure we can see we have 2 perfect squares, x squared and y squared, and they're being subtracted. So we call this the difference, that's subtraction, of squares. It's the difference of squares. And what you'll notice, I'll come back to this in a minute because I just want you to see where that's coming from. In order to factor this, basically what that means is in order to get this to look like that, 2 sets of binomials, we follow 3 quick, easy steps, okay? We take the square root of the 121. So I'm just going to put a little square root sign there and here. And when you do that, you get 11. You then take the square root of the 25, all right, and the square root of y squared, right? And when you take the square root of 25, you know that one. That one's 5. And then you take the square root of y squared. When we practiced solving radical equations back in Unit 5, we learned that those were opposites. So that just cancels and leaves you with y. The squared and the square root cancel each other out. So essentially, these are the 3 pieces that are going to create our answer. And the way the answer is created is you have these 2 binomials, okay? We have these 2 binomials here at the bottom, and basically what happens is the first square root, the 11, goes in the first position in both of them. So in the first binomial and the second binomial, you have an 11 there at the front and the 11 at the front of the second one. And then the 5y, since those were together, they stay together, 5y goes in the second position and the second position. Basically, whatever position they were in, so this was in the first position and this was in the second, right? And that's actually our answer, 11 plus 5y times 11 minus 5y, two binomials that are being multiplied together, which is what we did a couple days ago when we were multiplying our binomials. Now our answer is the opposite. Instead of multiplying, we're actually dividing. Factoring is actually a very fancy way of just saying divide. We talked about that yesterday, right? So it's important that we recognize that, hey, we're going the opposite direction. And your binomials are exactly the same except for one thing. The only thing that's different are the signs. One's plus and one's minus. And that will be the case every single time. So we looked at all 6 of these. Now we're just going to jump in and we're going to factor them. And the reason why we're starting with this is because if you recognize those 3 characteristics, if you recognize those 3 things, 2 terms, subtraction, perfect squares, then you just kind of snap your fingers, wave the magic wand, and you get your answer. So what I want you to do next to the notes for each one of these is just put 2 binomials next to each one, right? Wherever you have the space. Okay, so binomial, binomial. And we actually already know that their signs are going to be opposites, but we'll come to that. So we look at the x squared and we say, well, what's the square root of x squared? The square root of x squared is x. So that goes in the first position of both my binomials. What's the square root of 16? It's 4. So far my binomials are exactly the same, but the only thing that makes them different is one is plus and one is minus. And that's it. That's our answer. Okay, so this one will go a little faster because we're starting to get the hang of it. If we take the square root of 25, we get 5 and 5. If we take the square root, don't get fooled. If we take the square root of x squared and y squared together, no problem, xy, xy. And again, the only thing that makes them different, one's plus, one's minus. This is what we're doing today. This is what it means to factor the difference of 2 squares. All right, so the only other thing to do here is just to practice. So take a minute, press pause on this video, and then see if you can factor these the same way we just tried, and then you can come back and check your answer with me. All right, so if you got the right answer, you should have ended up with 9x plus 2, square root of 81 is 9, and 9x minus 2. All right, same binomials except for the signs. Same goes for the 4x squared. You square root that, you get 2x and 2x. And when you take the square root of 1, you still get 1, right? That doesn't change. Square root of 1 is 1. So hopefully you're starting to see the pattern. But the challenging part about this, it seems really easy right now, is that right now every single one we're doing, I'm telling you, fits this pattern. It's going to be harder for you to recognize it in the moment. When it happens and you're doing practice problems, they're all going to be mixed together. You've got to be able to recognize them in the moment. So in the next video, we're just going to practice a few more, and then there's a bunch more on your notes for you to practice. So the lesson's a bit shorter today, but I really want to make sure that you feel confident when it comes to the difference of 2 squares.